All right, so we're going to discuss conic sections. They're called conic sections because they're shapes that can be created by having a plane slice through a cone. For example, if this plane slices through this cone perpendicular to this axis through the middle, then the shape you get is a circle. It's like a special kind of ellipse. Now, if the plane slices to the cone parallel to one of the sides, the shape you get is a parabola, parallel to the generating line. Circle is perpendicular to the axis. Now, if you're between parallel to the side and perpendicular to the axis, the shape you get in between here is a stretched out circle, an ellipse, And finally, if you're not between, if you're outside of the axis and the generating line, the shape you get, funny name, it looks like hyperbola, it's pronounced hyperbola. It looks like hyperbola, it's pronounced hyperbola. Like this is not pronounced parabola, it's parabola, and that's hyperbola. It's like hyperbole in English, extreme exaggeration. Same idea here. And of course, if you take this parabola, which is parallel to the generating side line, and slide it this way, the shape you get is just a line. It's tangent to the side. So the circle, perpendicular to the axis, the parabola, parallel to the generating line. The ellipse is between, perpendicular to the axis and parallel to the generating line. And the hyperbola is outside of, if the plane is outside of, perpendicular and parallel. All right. Conic sections are also defined in terms of distances. For example, a circle is a set of points equidistant from a center point, and that distance is called the radius. That point's called the center. We've been doing that in our top 10 problems. If instead of a single center point, if you have 2 points, and you take all the points where the distances between those two are a constant, the shape you get is an ellipse, not an eclipse, but an ellipse. Give you an example. In an ellipse, any 2 points have the same distance from these 2 points, which are called foci, the plural of a focus. D1 plus D2, let's say they equal 20. Well, if D1 plus D2 equals 20, guess what D3 plus D4 equal? Also 20. In fact, how about over here? Sorry, that was a bad line. If D5 is 12, how big must D6 be? 8, because the total has to be 20. For any 2 points, any point on here, the distances from these two are a constant. It's like if you took a string and tied it in 2 places and stretched it out here with a pencil and began moving the pencil around, the shape you would get would be an ellipse. If the string is 20 inches long, then every point over here, the sum of those 2 pieces would be 20. Hyperbola. A hyperbola, the distances from the foci, or the focuses, from the foci, the difference is a constant. D2 minus D1 is a constant. Let's say it equals 30. Then guess what D3 minus D4 would also equal? 30. These differences, the difference of the distances are a constant. So a constant difference in distance for a hyperbola, a constant sum for an ellipse, and just a constant radius for the circle. Finally, we have a parabola. Now, in a parabola, doesn't involve 2 points, it involves 1 point and a line. The distance from that point and that line are always equal. Every point on the parabola, the distance between the point and the line are equal. The distance between the point and the line are equal. If D1 equals 3, D2 also equals 3. If D1 equals D3 equals 5, D4 also equals 5. These distances are equal. So it says hyperbola, that should be parabola. That should be parabola. All right, so algebraically, a circle has this form where you have ax squareds and bx squareds, and they're equal and positive. A and B are equal and positive. An example might be something like this: 3x squared plus 3y squared minus 2x minus 7 equals 0. In an ellipse, A and B are positive, but they don't have to be equal. They can be, and then it's a circle. It's kind of like a rectangle is a square, but just a square is a special kind of rectangle. Well, a circle is a special kind of ellipse. So if A and B are both positive and different, we're going to say it's an ellipse that's not a circle. An ellipse that's not a circle. Now, suppose there's only one squared. Suppose only x's are squared. Then it's a parabola. One square is a parabola. Two squares, x and y squared, A and B are equal and positive, it's a circle. A and B are positive but different, we're going to say it's an ellipse that's not a circle. If you have only one squared term, only x or y, it's a parabola. If you have no squared terms, what you remember from what we did before spring break, that's a line. And finally, if A and B have opposite signs, it's the hyperbola. It's the hyperbola. It's the shape that looks like a hyperbola. Graphically, it could open left and right, or it could open up and down. And if x is positive, it opens left and right. If y is positive, it opens up and down. So let's look at a test question. The plane slices the cone perpendicular to the cone's axis. Perpendicular to the cone's axis. What shape is perpendicular to the cone's axis? It is a circle. The plane slices the cone parallel to the side. The shape is a parabola. The plane slices the cone between parallel and perpendicular, between parallel and perpendicular to the axis. That's the ellipse, which is not a circle. Some ellipses can be circles, but that's the ellipse that's not a circle. The plane slices the cone between parallel to the side and parallel to the axis. On the outside of that, that's the hyperbola. Now, what do we call it where all the points have an equal distance from a central point? That is a circle, which has a common sum from 2 points called the foci. That is the ellipse, not the eclipse, but the ellipse. What has a common difference from the 2 points? That is the hyperbola. And what has an equal distance from a point and a line? The point is called the focus, the line is called the directrix. Equidistant from a point and a line, that is the parabola. Not parabola, the parabola. All right. Now, when they're in this form, equal to 1, circles, ellipses, and hyperbolas, there's some information we can tell by looking at the equation. For example, if I wanted to graph this, the center would be at positive 3, negative 5. The center would be at positive 3, negative 5. And it would stretch a distance of 4 in the x direction and 7 in the y direction. And that would be my ellipse. It's an ellipse. In this case, this is kind of tricky. It's going to involve a fraction. But you have 1/16 x squared. If I FOILed this all out and divided it by 16, I'd have 1/16 x squared. And if I FOILed this all out and divided it by 49, I'd have 1/49 y squared. So looking at the chart above, x's and y are both positive, but they're different. This is 1/16. This is 1/16, and this is 1/49. So they're positive but different. That makes it be an ellipse. That makes it be an ellipse. Now here, x squared is 1/81st, and y squared, hold on tightly, y squared is negative 1/25th coefficient. Why negative? Because it's minus there. So x and y have different signs. That makes it be a hyperbola. And because x is positive, it's going to open left and right. Now the center of the graph would be at positive 4, 0. The center of the graph would be at positive 4, 0. It would stretch 9 in the x direction, 9 in the y direction, and 9 left and right, 5 up and down. And that would kind of make a box that I would use to draw my hyperbola. That would kind of make a shape box. Let's look at that again. Now I went kind of fast on that. How do I know it's a hyperbola? Because they have different signs. How do I know it's left and right? Because x is first. Because x is first. The center, like we do with our circles in our top 12 problems, is positive 4, 0. It stretches 9 in the x direction. It stretches 5 in the y direction. 9 in the x direction, 5 in the y direction. But it's a hyperbola. So that just kind of gives me an outline that I'm going to draw the hyperbola from. The center at 4, 0, I'm going to go 9 in the x direction, 5 in the y direction. I'm going to make a box out of that. And if I connected these corner points here, again, I know it opens left and right. It's going to kind of mirror those diagonal lines I just drew. I'm not going to ask you to sketch that. That would be kind of hard to do on the computer, but that's the idea. Let's look at this next one. What shape is that? Because it's minus, I have two squares, x squared and y squared, but it's a minus between them, makes it be hyperbola. And this one opens up and down because the y is the positive one, so it's going to open up and down. And the center, be careful, what's the x number? The x number is 1. The y number is -3. There's my center. 1, -3. It's going to stretch 4 in the x direction. We call that the minor because it's the lesser. 5 in the y direction. But that doesn't give me the shape of the hyperbola. That would give me the shape of the ellipse. But for the hyperbola, that just sets up the box, connecting these corner points here. This one opens up and down, so I can see that the shape is going to kind of mirror those lines that I've drawn over there. And that's what the hyperbola would look like. All right, so circle, ellipse, hyperbola, or hyperbola. Let's look at this one. I got a plus. I got two squares, and I got a plus. I've got two squares, and I have a plus. But because these are the same, that tells me it is a circle with the center of +1, 0, and the stretch in each direction is 5. And finally, in a parabola, we don't really have a center. We have a vertex. This one opens sideways to the left because you have a negative x squared in there. And the vertex is what makes that 0, which is -3. And if x is -3, that becomes 0, so y would be 16. Let's look at that again. For the vertex, what makes that 0? -3. And if that's 0, then what does y equal? 16. What makes that 0? X is 2. Sorry, that opens up and down. I said left and right, that opens up and down. And if x is 0, or if x is 2, this thing is 0, so what does y equal? 9. Now, how do you find the intercepts? You find the x-intercept. Y'all may remember this from our lines. How do you find the x-intercept? What do you let equal 0? You let y equal 0. So you find the x-intercept by letting y equals 0. If you pull that over and change the sign, you get positive x plus 3 squared equals 16. Or x plus 3 equals, remember your top 12, what does x plus 3 equal? 4 or negative 4. So x is 1 or negative 7. The y-intercept, how do you find the y-intercept? You let x be 0. So if x is 0, then that becomes negative 9 plus 16. My y-intercept is x is 0, y is 7. Once again, my vertex is negative 2, positive 9. The x-intercept, you let y be 0. Or negative x plus 2 squared equals 9. Or x plus 2 squared equals negative 9. And since you cannot square to get a negative, there's no x-intercept. How do you find the y-intercept? You let x be 0. So if x is 0, that says 4 plus 9. The y-intercept is 0, 13. Once again, how do you find the y-intercept? Let x be 0. How do you find the x-intercept? Let y be 0. Let's look at some more test questions. I have 4x squared and 4y squared, and they're both positive. What shape is that? If they're positive and the same, that is a circle. I have 3y squared and 3x squared and 2y squared, but minus, so that would be positive 3 and minus 2y squared. They have different signs. What shape is that? That is a hyperbola. This one has only one square. What shape is that? When it has only one square, that is a parabola. This one has no squares. What shape is that? That is a line. Now, don't think because I've used B, C, D, and E, the next answer is A. It is not. I'm very likely to give you 5 answers, but only use 4 of them. This last one has only one square. What shape has only one square? The parabola. D was used twice. A was never used. Let's look at this one. You have 1/16 x squared and 1/25 y squared. They're both positive, but they're different. That is an ellipse. You have 1/16 x squared and minus 1/25 y squared. That's a hyperbola because it's minus, but because the x is positive, it opens left and right. You have only one squared, only x squared, no y squared. That's a parabola. And you have 1x squared and 1y squared, and they're positive and the same. That shape is a circle. All right, now this is a little more complicated. My center right here is positive 3, negative 1. The stretch in the x direction, if you count those steps, the stretch in the x direction, I'm going to call it the x radius, it's not really a radius, is 5. And the stretch in the y direction is, if you count those steps, 3. And it opens up and down. It's a hyperbola, opens up and down. If it opens up and down, which one is positive, the x squared or the y squared? The y squared. So, if my center is 3, negative 1, then my equation is going to be y plus 1 squared over 9. Y plus 1 squared over 9 minus x minus 3 squared over 25. X minus 3 squared over 25 equals 1. How did I know minus? Because it was a hyperbola. How did I know to put the y's first? Because it opened up and down. Let's look at this one. The center is 2, -3. And the stretch in the x direction, if my x number goes from 2 to 7, the stretch in the x direction is 5. If my y number goes from -3 to -12, or from -3 to +6, the stretch in the y direction is 9. Since this is a circle, it's going to be plus. And if that's the center, it's going to be x minus 2 squared over 25 plus y plus 3 squared over 81 equals 1. This standard form is where we make it equal 1. We divide it out so it has to equal 1 to put it in that standard form. All right, we have a hyperbola. This one opens left and right. What does that mean if I have a hyperbola opening left and right? It means that the x has to come first. The x has to come first. All right, and the center here, if you count, is -1, -3, so that's going to be x plus 1, y plus 3. The stretch in the x direction is 5, so that's going to be 25 under the x term. The stretch in the y direction is 3, so that's going to be 9 under the y term, and in this standard form it equals 1. All right, we're running long on time here. Let's go to our test prep problems. Here we go. How many squares? 2. Are they both positive? No. That makes it be a hyperbola. How many squares? 2. Are they both positive? No. That makes it be another hyperbola. What did I try to trick you with? Well, I tried to trick you with both of those being 4 and have you saying that's a circle. If that were a plus, that would be a circle. But both of those being 4 doesn't mean anything if they're opposite signs. If they're opposite signs, it's the hyperbola. All right, 2 squareds, but different coefficients. That's the ellipse, which is not a circle. It's not the best description. No squares. That shape is a line. And finally, 1 square. That shape is a parabola. Same idea. X squared and y squared, but we have different coefficients, positive but different coefficients. That is an ellipse. I have only 1 squared. Y is not squared. Y is not squared. I have only 1 square. That is a parabola. I have 2 squares, and they both have coefficients of 1. That's just like one of your top 10 problems. That is a circle. B for a circle. And I have 2 squares, but they're being subtracted. That is a hyperbola. And because the y comes first, because the y is positive, it's going to open up and down. So what is this shape? You have x squareds and y squareds with a minus in between there. What is that shape? That is an, nope, it's a hyperbola. Now, because the x is first, it opens left and right, and the stretch in the x direction is 6 for the shape box, and the stretch in the y direction for that shape box is 7. Okay, this has got a plus, and they're the same. That makes it be a circle with the center. Oh, I forgot the center. The center here is +3, -5, just like we do in our top 12. +3, -5. My center here is 0 and -8. My center is 0 and -8. And the radius is 5. All right, looking at this one, what is my vertex? Well, what makes the x number 0? 5. And if x is 5, this whole thing is 0. So what does y equal? -36. How do you find the x-intercepts? Y equals 0. Or sorry, that's -36. I don't know where I got the 16 from. I don't know where I got that 16 from. It's -36. Pull that over, I have -x minus 5 squared equals -36. X minus 5 equals positive or -6. X equals 11 or -1. How about the y-intercept? How about the y-intercept? How do you find the y-intercept? You let x be 0. And if x is 0, that says 25 minus 36. So the y-intercept would be -11. If x is 0, the y-intercept is -11. And finally, we're running almost on 30 minutes here. Going back to our definitions, if I slice the cone perpendicular to the axis, perpendicular to that axis, the shape I get is a circle. Parallel to the side of that cone, the shape I get is the parabola. And if all the points have a common sum, that is an ellipse. All right, y'all have good luck with that. I'm going to put something online for y'all to practice on that with, and I'd expect to see that on your final.